My name is Cristian. I hope you are liking so far the conference. And next we have one of our sponsor talks. It's the only champion sponsor that we have, and it's a company that you might know, Meta. They have been developing lately many things, and most of them are focusing in open source. One of these topics is type hints, and the other one is how to embrace the new features of Python. So next, let's welcome Abby Mitchell that will talk us about what they have been doing recently about Pyrefly and free-threaded Python.
Hi everyone, my name is Abby. I'm a developer advocate at Meta, and in this session I'm going to give you a super quick whistle-stop tour of some of the open source initiatives that we've been focused on this year. We're going to talk about two different initiatives. One is called Pyrefly, which is a tool for Python developers that we have been developing and open sourcing. And the other is free-threaded Python, which is actually a feature for Python itself that we've been playing a significant role in upstreaming to CPython. So we're going to start with Pyrefly. I'm just going to give you a really quick overview of what this project is, but before we can really dive into the project, we need to have a short recap on typing in Python. So typing has been available for Python developers since version 3.5, so that was around 2015, was introduced first with PEP 484, and essentially since then we've been able to use some form of annotations in our code to indicate what the type of something should be. Like in this example up here, x is of type int, and this function returns a type string. But in Python, we don't check this at runtime. Like if you passed a string here instead of an int, you wouldn't get, it wouldn't fail, right? It wouldn't make any noise at all. So it's something that's very, and this is like kind of unique with Python, is we allow you to use types, but we don't enforce them in any way. And the typing system that has sort of evolved since that original PEP 484 is more complex than you might think. There's lots of different aspects to it, and the standards are constantly evolving. There's a lot of debate in the typing sort of enthusiast circle about how do we do types, how do we enforce them, etc., etc. But generally speaking, there's a few reasons why everyone agrees that like typing is a good thing to do. Once you get to a certain maturity of project, it can help you spot typos in your code. It can help you make edge cases a little safer. And if you're using an LLM, for example, and you're writing typed code, it's the LLM can get more information from it and actually give you more sort of accurate results out. There's a whole host of reasons why you might want to use types, but because it isn't enforced at runtime, that's when you might want to use a type checker, which is where Pyrefly comes in. Pyrefly is an open source project. It is a language server, which means that if you're running Python in your IDE, you can get features like autocomplete and hover. And it's also a type checker, so it can provide type diagnostics for you, like little red squiggles. We just released a beta version of this like very recently, so it's still a fairly new project, but it's slowly becoming more and more mature as we fix more bugs over time. Here's just like a bit of a visual example of what it means to have Pyrefly installed in your code editor. So all of the sort of the syntax highlighting you're getting and the hover on this piece of code, that's all powered by a language server, the Pyrefly language server. But this red squiggle here, it's sort of indicating that you have something is wrong here. This %cacao doesn't exist. There's actually this %cocoa thing. And that red squiggle is the type checking diagnostics that Pyrefly is doing. So that's just a little example of how Pyrefly works. And a really key component of Pyrefly and the development of this project was we wanted to make it super performant. We have pretty large code bases at Meta that use Python. And so we were finding internally that, the tools that we were using before just were not good enough to run on such large code bases. So that's why we built Pyrefly the way that we did. It's based in Rust, and it's designed to be as performant as possible. Here's just a few statistics for you that we've run recently. And as we've been improving it and getting better and better, we've reached a major milestone recently. So we can now say that Instagram developers are using Pyrefly in their IDEs to develop Instagram on a daily basis. And we've done some benchmarking on how much faster Pyrefly is. There's these numbers maybe don't mean much to you, but you can say that in such a massive code base like Instagram, it went from when you hover over something, it could take multiple seconds for that, hover to complete and for you to get that information, to, it being very seamless and milliseconds. And that was like a real tangible difference that we were seeing. It's also super fast to, get it started up. Here's like a side-by-side comparison. On the left, we have Pyrefly, like it already appeared, and Pyrite takes much longer. It's like a little timer there for you. I can probably play it again for you. There you go. So here's Pyrefly on the left, like hover appears instantly. Pyrite is still taking multiple seconds. Like this isn't like kind of a toy example, but on a code base like the size of something like Instagram. So where can you get Pyrefly? You can either install it in your command line, or you can just find it in your favorite IDE marketplace. There's extensions available in VS Code, PyCharm, Cursor, Windsurf, anything that uses the OpenVSX type of extensions, that's all there. And if you go to pyrefly.org, that's the main website where you can find all the documentation. There's also a nice sandbox there if you want to play around with how to use Pyrefly before you install it. Okay, now let's talk about free-threaded Python. So we're shifting gears a little bit, and we're going to talk about concurrency. So before free-threaded Python was a thing, there were typically these like two main methods of doing concurrency in Python. Threading, which is typically used for IO-bound code. What does that mean? It essentially means where you have like a lot of external requests being the bottleneck for your program. So if you have API calls and things like that. And the other method was multiprocessing. Multiprocessing is more used for CPU-intensive code, so you're not dealing with a lot of external requests, but you maybe need to crunch a lot of numbers. If we take a look at this in a little bit more detail, you can imagine in a sort of when you might want to use multiprocessing is when you're doing a lot of chunks of work on one CPU, and actually it would just be easier if you could like parallelize that by doing processes on three CPUs concurrently, which should in theory be a lot faster. There are some reasons though why we don't use this in every case. Another colleague of mine made this wonderful diagram that I had to include. But multiprocessing can become challenging when you have to move a lot of data around, because there's costs to spinning up a new CPU, to like sharing memory or like passing data between the CPUs and things like that, which is the main reason why we typically use it more often just for the CPU intensive workloads and less for those IO bound workloads. So for those more IO bound workloads, that's when we would typically use threading. The way that this works is, you spin up different threads to handle different requests. And in this example, we're showing how you can sort of get requests to be handled concurrently by having like the threads like start, even though the requests are still happening at like kind of this sort of same time, the threads themselves, you can see are very clearly like starting and stopping. Like we have to finish one thread before we can start another, even though the request itself hasn't fully completed. If we want things to go faster, we would love to be able to like do all these threads in parallel like we did the multiprocessing. But there's a reason we can't do that, and that is the GIL. The GIL stands for the Global Interpreter Lock, and essentially what it prevents is it prevents multiple threads being executed by Python simultaneously. So yeah, that's what these little lock animations represent. Like, we can't do these things on top of each other because you have this global interpreter lock that's preventing those threads from overlapping. So even if we did split them across multiple CPUs like this, we could do that, but it still we wouldn't get any benefit from doing that. And in fact, this would actually be slightly slower than if we just did it on a single CPU. So in an ideal world, we'd like to be able to do something like this, where we could have this threading set up, but be able to span it across multiple cores. And that is where free threading came from, and free threaded Python. The original name for free threading was actually no GIL, because it removes the global interpreter lock to allow you to run threads in parallel. It reached supported status earlier this year, which means that in the latest version of Python, you can opt in to use it, but it's not available by default yet. There's still some edge cases that need working out before we get to that stage. This technique should pretty much, I think, most of the time be better for IO-bound programs, but what's really interesting is this can also be, in some cases, even better than multiprocessing for the CPU-bound programs as well. If we take a look at, this is just a toy example of a CPU-intensive workload. We've got multiple for loops, maths operations, about 2,500 operations happening at once. This is when you might want to use traditionally multiprocessing. And we find if we just throw free-threaded Python at this and like make this into a free-threaded program and don't do anything special, we can see it's always going to be better than threading. But it's only better than multiprocessing some of the time, so for smaller workloads. So why is this? On the one hand, free-threaded Python is still very new. Multiprocessing has been around for a while and has been much more optimized at this point. Free threading is still experimental at this stage. We're still working out some kinks. And the other reason is that you can't just throw any random Python program and make it a free-threaded program and have it and get all the benefits of free threading, because we now need to actually start writing thread-safe code, which isn't something that we've necessarily had to think about before now. We have to now think about things like cache invalidation or race conditions or like all these other things that, you know, up until this point, like as a Python developer, you probably didn't think twice about. So I don't have the time to go through like how we can change that example specifically, but I will just call out that another sort of side smaller project that we've been working on at Meta is this ftutils library. It's an open source project still being actively worked on, but this is meant to be a utility library to help you convert your Python code into something that is thread safe so that you can see the benefits of using free threaded Python. And if you do the work to refactor your code, make it thread safe, maybe use the free threaded utils, like we can see that it can give you benefits over even multiprocessing. There are other talks out there that goes through this example in a lot more detail, but I have limited time here, so I'll just throw up the last slide with a few helpful links if you want to learn more about free threaded Python. And that's pretty much it for me. I hope you enjoyed this talk. Check out all those links if you want to learn more about Pyrefly or free-threaded Python. And yeah, thank you very much for listening.
And did you like all the things that Meta is doing? I really invite you now to drop by the channel, our champion sponsor, and maybe leave some questions for the speakers. And maybe you are more motivated now to move to a newer Python versions or start using Pyrefly. Thank you.